So this question I had asked you to do by yourself. Yeah. The maximum number of points of intersection of a square and a circle is 2. Sorry, minimum number. Minimum number of, say, you take a circle and you take a square. You take a circle and you take a square. I'll take one random square. And I'm trying to intersect them. Okay? I'm trying to intersect them. First, we'll go from the extremes. Extreme in the sense, the minimum number of intersection that a square can make with a circle. Let us go with 1. 1 is the minimum possible thing. No, let us see. Can we have only one intersection? Let's say I draw like this. And I draw like this. I'm sorry. Not to perfection. Yeah. Now, this is getting connected here. Yes. This line or this side of a square is what to the circle? Definitely you have forgotten this word. This line is what to the circle? Is it getting inside the circle? It is just touching the circle. It's just grazing over the circle. It's a tangent. So, how many points will be there for a tangent? When a tangent is drawn to a circle, how many points? At how many points it will touch? Single point. That is the understanding. But practically we can't show. It will have more than 1 point. Practically we cannot show. If we have a very thin circle and a thin square, then we can say, yes, but it is not called as what? Intersection. It is not called as intersection. It is just a tangent. Getting my point? You cannot call it as intersection. Intersection means like one has to get inside other and come out. Getting my point? Touching is different and intersection is different. Can you understand? Now next possibility is what? This, right? Next possibility is this. After that, one is done. We cannot call it as intersection. This is tangent. This is not intersection. This is proper intersection. How many points? 2 points. Here 1 and here 1. Correct? Yes or no? Yeah. Next chance. Next chance. I'll draw a circle. Can we connect or can we intersect a square with the circle at 3 different points? At 3 different points? Can we? Can we? Try. Try. Four. Yes, sir. Okay, show. Four. Yes. 4. Possible? But that has to be a square. Is it a square? See, when you take a square, the minimum possible thing, this is not. When all 4 are touching, yeah, it can be a rectangle, it can be a square also. But you cannot, what? You cannot the way you have drawn, like she has drawn like this. It is not a square, it's a rectangle. We cannot consider this. Okay, now tell me minimum intersections, 2, right? Minimum intersections 2. Okay, 3 not possible. 4. Rectangle, yes, possible. But for a square, it's not. What about 5? Don't think of odd numbers at all. It is not possible. Don't think of odd numbers. Then 6 also not a possibility. The next best thing that can happen is what? Can we? Can we? Yes. See, without intersecting, what all are the possibilities? I'll tell you. This is one possibility. And another possibility, yeah, can you just imagine that? This is also touching this, okay? But here, these are tangents to a circle. And these are not intersections. They are points on a circle. So, next best thing that can happen is only this. So, minimum number is 2. Maximum number, 8. Okay. Fine. Don't tell it to anyone, okay? Minimum number of intersections are 2 and maximum number of intersections are 8. Yes, 6 not possible, 4 not possible. Don't think of odd numbers at all. Don't think of odd numbers at all. Okay, done? Cool. For any polygon, you don't think of odd numbers. Intersections will be only in even numbers. Okay. If it happens in odd numbers, the other has to be tangent. Other has to be tangent. Okay. So tangent is not an intersection. So that is why whenever we take intersection, there have to be 2 points minimum where the intersection is happening. And maximum here in this case, it is 8. What about triangle? Triangle and a circle? Triangle and circle? 6. Yes. Minimum 2. So minimum is 2. For any diagram, minimum is 2. And maximum depends upon how many sides it has. Okay. In triangle, 2 and 6. In square, 2 and 8. If you take pentagon, you can just imagine 2 and 10. Like that. You keep this thing in mind. And this is a new invention. New invention in the means, it's a new learning. Only after this question has come in the examination, we go to, I think last year it has come. Okay. So with that knowledge, you can solve for other diagrams also. No? Yeah. So here, both the statements are right. Both the statements are right. Yes. Any other thing? No. Next. On a chessboard, in how many different ways can 6 consecutive squares can be chosen on diagonals along a straight path? They are asking about chessboard. Chessboard. Bear with me for some time. I'll draw a chessboard for you. Okay, fine, no? Okay, adjust. Okay. Yeah. Now don't mark black and white, okay? Not needed. They are asking what? In how many different ways can six consecutive squares, they want six consecutive squares on diagonals. Diagonals, this is one diagonal and this is one more diagonal. Okay. Now, on these diagonals, can you trace the squares? If you draw the diagonal, okay, better I don't draw. Okay, so these are the squares 1, 2, 3, 4, 5, 6, 7, 8. Similarly, 1, 2, 3, 4, 5, 6, 7, 8. These are the squares that they are meaning. What they are asking? Six consecutive squares. Okay, I'll take six consecutive squares starting from here. 1, 2, 3, 4, 5, 6. This is one way. Other six consecutive. Start from here. 1, 2, 3, 4, 5, 6. 2. Then 1, 2, 3, 4, 5, 6. How many? 3. Come in this manner also. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. How many totally? 6. Yeah. Any other thing that is possible? On diagonals. On the diagonals. Reverse from here. Same thing, no? We have counted, no? Let's say start from here. 1, 2, 3, 4, 5, 6. Already we have done this, no? Why you will take that again? This chunk from here to here is already taken. Why you will reverse? Okay. So 3 like this and 3 like this. 6. Done. Any other way? Don't consider these, okay? Because these are not on diagonals. These are next to diagonal. These are not on diagonal. So these are the squares on diagonal. So totally 6. Any other thing? Any other thing, like, can we do anything else apart from this? On diagonal, strictly 6 squares. Consecutive squares, that too. Done? Yeah. Next. 9 different letters are to be posted or to be dropped in 3 letter boxes. In how many different ways can this be done? How many ways? Nine letters are there. You have gone to a post box. There are 3 post boxes. You are given a job to drop. In how many different ways you can drop? Okay, let's say, have you seen the number lock? Number lock? 3-digit number lock? Yes? 3-digit number lock you have seen, no? How many ways you can try a password? Definitely you have forgotten many a times. How many ways, how many trials you have to make to get the password? Huh? See, number lock will be having 0 to 9, 0 to 9, 0 to 9. So first digit can be tried in 10 ways. Second digit can be tried in 10. And third digit, 10 ways. 10 into 10 into 10. 10 to the power of 3. Are you getting the crux? Yeah. Passwords. Our, what? ATM passwords. 4-digit, right? If a fraudster wants to, steal your money. Steal your money. He has got your, what? The ATM card, and he wants to draw some money. How many ways he can try? How many ways? Every digit, 10 options. 0 to 9, 10 options. 10 to the power of 4. So that is why the security system will get more robust when you increase the number of digits. Or sometimes that digit can be even alphabet. What if the alphabet is there? 26 alphabets. If you have 4 digits, 26 into 26 into 26 into 26, 26 to the power of 4. So that is the number of ways. Now here we are trying to drop letters. Where? Where we are dropping? Boxes. Imagine the situation. You have letters. Take first letter. How many ways you can drop? One letter. 3 ways. You are not taking post box and dumping into the letter box. Yes. So you take the first letter, and how many ways you can drop? Second letter. Fourth letter. Third letter. 3 into 3 into 3 to the number of letters. So 3 to the power of 9. Fine. In such cases, confusing thing will be whether it is 3 to the power of 9 or 9 to the power of 3. You choose a thing which has to be put in what? Let's say there is a envelope and there is a letter. Envelope and letter. Envelope is a bigger thing, no, in which you will put this one. Here, the post box is bigger thing, in which you are putting the letters. Or you take a bucket and you put a ball. Heavier things or the bigger things in which you put the other things, keep that in the base. Here post boxes are heavy and you have to put letters in that. Keep post box as the base. So base is 3 and power is 9. Look at the number of letters which are going inside. So make them fly on the top. Base is bigger in the sense like in which you are putting other things. Yeah. And what you are putting, that has to come in the power. Understood? So this clarity should be there. Done? What if 3 letters were there and 9 boxes are there? What if 3 letters are there and 9 boxes are there? First letter 9 ways. 9 into 9 into 9. Done? Yeah? Next. This is a typical problem. This is a typical problem. This is called as dearrangement. This is called as dearrangement. So far we were arranging. Arranging in the sense, we were making the things to go to their place. We were making the things to go to their place and we were calculating in how many ways we can arrange. But here we are trying to dearrange. Dearrange in the sense, whatever the arrangement that has been given to us, that should be disturbed completely. That should be disturbed completely. For example, you have 2 letters and 2 envelopes. Okay. So letter A and letter B. And we have respective envelopes also. Envelope A and envelope B. A has to go into envelope A. B has to go into envelope B. This is arrangement. Dearrangement means you have to disturb the entire thing. A should not go into envelope A. B should not go into envelope B. So how many ways we can disturb? 1 way or 2 way? A will go to B and B will go to A. Only 1 way. This is 1 way. Getting my point? Okay, now let us take 3. A, B, C, A, B and C. These are letters and these are envelopes. What you will do? First, you will put A into B, B into C, C into A. This is one way of arranging. Other way, A has already gone into B, no? Now I'll send A to C. Then I'll send B to A and C to B. Disturbance means everyone has to get disturbed, not just two. Let's say you don't consider C, A is put in B, B is put in A. Then what about C? C has to go inside C only, no? That is not called as dearrangement. Getting my point? All of them should go to different destinations. All of them. Yes? Now tell me. 4. A, B, C, D. A, B, C and D. First one, A will go to B, B will go to C, C will go to D and D will go to A. Possible? Yes? No issues? Then A, B, C, D, A, B, C, D. Now, A will go to B, then B will go to A, C will go to B, D will go to C, B will come to D. From 4, it is very cumbersome. You can't write it and execute. You cannot write it and execute. Up to 3 you can imagine. Up to 3 you can imagine. Beyond 3 it gets out of control. That is why we have to remember one method. For that we have a set formula. Set formula. You can write the number of D arrangements. Number of D arrangements is equal to n factorial and inside bracket 1 divided by 2 factorial minus 1 divided by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. It will go up to 1 divided by n factorial. It starts with 2 factorial. Then the denominator will keep on changing like 2 factorial, 3 factorial, 4 factorial like that. And the signs will get changed. Even numbers will get plus, odd numbers will get minus. You can try. Now for 4, number of arrangements when n is equal to 4. When n is equal to 4, how do we write? 4 factorial, 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. So 4 factorial is what? 24. 1 by 2 minus 1 by 6 plus 1 by 24. 1 by 24. Take the LCM. You better put 24 only because you have to cancel this 24 later. So here 12 minus 2 plus 1. So this is equal to 12 minus 6 is 6, 6 plus 1, 7. So answer would be, am I correct? So here 4, no? 4. So answer is 9. So when 4 letters and 4 envelopes are there, if you want to make some fun, you can make in 9 different ways. You can make in 9 different ways. Yes? Okay. Check for 2 and 3. Check for 2 and 3. First we'll check for 2. N factorial. 2 factorial into 1 by 2 factorial. 1, no? Check for 3. N factorial is 6. Here 1 by 2 minus 1 by 6. 1 by 2 minus 1 by 6 is 1 by 3. 6 into 1 by 3 is 2. For 3 it is 2. For 4 it is 9. So it will go on increasing for 5, 6 and all. Yeah, I know. This is bit difficult to, like remember. But here, just to start, see 1 by 1 factorial, it doesn't have any significance. So 1 by 2 factorial you start. Then write all the things and keep on changing the signs. Even number will get plus, odd numbers will get minus. Done? But very rare problem. But they can ask. They can ask. Done? Okay, no? So this is all what I have for permutations and combinations. Beyond this also, there are plenty of problems. But looking at the examination standards, I am restricting myself to these 37 or 38 problems. Okay, that is enough. Fine. Now, we'll go to probability, which is an application, or it depends upon what we have learned so far in permutations and combinations. Okay. Again, probability, this is also like oftenly used word in our day-to-day activity. Yes or no? Most probably. Yeah, probability is more. Probability of me coming to your house is like 50-50. Yeah. So the way we use percentage, in the same manner, we use this probability also. But when you speak in terms of probability, people will come to know like, oh, this person, probability, this person must be knowing probability. So what do you mean by probability then? Chances of occurring. Chances of occurring. What is the maximum probability? One. Probability 1. You are going to somebody's house, you have promised and you have gone. If you told initially 50-50, then that person will understood. Like only when your call comes, let him or let her get ready. Understand? So here, when we say certain event, that means something is happening. Something is happening. Something is happening. And when we say a sample space, for example, no, I'm not getting this one. For example, yeah, I'll take the rolling of a dice. Rolling of a dice. Dice, you know, right? How do you roll? This, anything is fine. You cannot drop like this, just you have to roll. So what all are the possibilities? How many possibilities are there when you roll a dice? 6. So here, 6 is sample space. 6 is sample space means here all possibilities. Sample space means all possibilities. Events means these are like restricted possibilities. Restricted possibilities. Event. Okay. You have 6 chances when you roll a dice. Let's say you got 5. 5, that is getting a 5 on your dice is an event. But sample space is what? It is collection of all possibilities. Possibilities are 6. But getting 5 on dice is only 1 chance. So here your probability will become this is a restricted possibility or a desired possibility. So probability is what? All possibilities in the denominator, in the numerator, it is desired possibilities or desired entities. You can take anything because we are not going to write any theory exam for this. So generally in your books, it will be given like, this is the number of sample space, all possible events, and here like n of the event that has occurred. N of event that has occurred. I am not going to use these things anymore. I'm not going to use them, just for your reference. Okay. So in the denominator, you will write all possibilities. And in the numerator, you will write what? You will write the desired event. Yeah. Now, simple thing. Coin. Unbiased coin. It is called as unbiased coin. Unbiased coin means you have two different faces. Different things are printed on two faces. Biased coin means on both sides you will get only one. Have you seen Sholay picture? Sholay. Yes or no? No. If you have not seen Sholay, then you have missed something in your life. At least your father or mother must have, like make you see that movie forcibly. I guarantee this one. Yeah. Because that time, 70s, it was a hit. So Amitabh Bachchan in that movie will be having one coin always. So whenever there is a dispute between him and Dharmendra, Viru and Jai, their character's name, okay, he used to flip a coin. And always Amitabh Bachchan knew that it is going to go in his favor only. And usually he used to call because he knew. So only after his death, Viru will come to know that it was a biased coin. It was a biased coin. So always in our question, we'll get unbiased coin means on the coins, you will have two faces. One is heads and one is tail. Again, don't ask me the questions like, sir, on heads, what should be there? In our Indian coins, heads will be having our national emblem. National emblem will be there on heads. On the tails, it is always the number. 1 rupee or 2 rupee. Now 50 paisa, 25 paisa are gone. 1 rupee, 2 rupee, 5 rupee, 10 rupee, like that. Yes? Okay. So when I flip a coin once, what is the probability of getting one heads? That is why we flip a coin, right? It is between two persons. One will call heads or one will call tails, and whoever gets their call, they win and they choose according to that. Yes? So what is the probability of getting heads? One by two, no? So here simple. Number of possibilities are what? When you flip a coin, what all are the possibilities that we have? Either it is heads or tails. Two, no? So that we write in the denominator. But we are expecting a particular desired event, that is heads. What is the chances of getting heads? 1 out of 2. So that is why the probability is half. Now if I call, what are the chances of getting either head or tail? Chances of getting either head or tail. Anyways, you flip a coin, it has to be either head or tail. One possibility is no. So when you go to a bus stop and ask the person there, like, whether this bus has gone, that person will say, this bus might have gone. If not gone, it will come. If not gone, it will come. So basically, he doesn't want to disappoint you. He wants to pacify you. It must have gone, but if it has not gone, it will come. So possibility is what? One. Either you will get a bus or you don't get a bus. So here, either you get a heads or tails, but one event will happen for sure. Yes. Let's say when I roll a dice, what is the chances of getting the number less than 7? When I roll a dice, 6 possibilities are there. No, I'll give a condition that when I roll a dice, the number that I read should be less than 7. What is the probability? Anything you get that is less than 7, no? So in such things, we call that event as a certain event. Either bus will come or it has gone. One or the other thing will happen, no? Yeah, today, it might rain, it may not rain. Probability of getting rain or not is what? 1. So these are certain events. Yes. When you flip a coin, yeah. When you toss a coin, yeah, getting heads or tails is certain event. When you roll a dice, getting the number less than 7 is certain event. Okay, if I ask, when I roll a dice, what are the chances of getting 7? What are the chances of getting 7? 0, no, not possible, because it is not in our sample space at all. So it is called as no event or null. Like this event cannot happen because on a dice, you can have only 6 numbers. 7th number will not come. So certain event is what? For definitely it will happen. No event, that is no chance at all. No chance at all. You go and write UPSC examination. Can you clear KPSC examination by writing UPSC examination? No, right? No chance. You might clear UPSC examination, but by writing UPSC examination, you cannot clear KPSC examination. You can prepare, but just by. So there are certain events, that means this will happen for sure. Let's say in KPSC, okay, under your caste category, there is only 1 seat. There is only 1 seat, and you are the only applicant for that seat. Then chances of getting selected is what? Sure, no? If there are 2 persons for that same seat, half. If there are 10 persons, what is your chance of getting selected? Yes. So we say in mains, 20% of the people will clear. 20% of the people will clear. So out of 5%, 1 person will clear for sure. So what is your chance of clearing mains when you are writing mains? 1 by 5? Yes. And when we go to interview, this probability is 2 by 5. This probability is 2 by 5. So out of every 5 persons, 2 will get selected. So even your chance of getting selected when you go to interview is 40%. Getting interview call when you have written mains is 20%. If you club both the events, when you write the mains, chances of clearing the examination is 8%. 40% into 20%, no? 40% into 20%. How much? 8%. So probability of you getting selected when you are writing the mains examination is 8 out of 100. Yes? Or it is 2 out of 25. In a hall, if 25 people are writing the examination, 2 of them will get selected. I mean, not necessarily that 2 from this hall only should get selected, but on an average, 2 will get selected. Yeah. So this is how we, talk in terms of probability. Talk in terms of probability. Yes, there are chances that in an examination hall, 25 persons are there. All of them might clear, or none of them might clear. But on an average, the probability is what? 8%. Yeah, 2% can clear. Okay. We'll start with smaller examples. I am not going to bombard with theory here. I am not comfortable with that theory. N of E, N of S, N of P. I have not learned that, and I will not teach also, and that will not come in the examination. If you are studying for +1, +2, I would have taught that one by learning myself. Okay, but it is not required here. Just understand the situation, solve. Okay, so the first basic example that I start with is a coin or tossing a coin. Tossing a coin. So when only one coin is tossed, what is the probability of getting heads? Half, no? What is the probability of getting tails? Sure? When two coins are tossed. When two coins. Imagine, don't think theoretically. You are flipping two coins together. Two coins together. What are the chances of getting both heads? Both tails? One head and one tail? Yeah. We have a certain way, certain method to write that. Okay, here we are tossing two coins. So usually we get the number of events as 2 to the power of 2 events. That means sample size is 4. When you toss two coins, the possibilities are 4. Those possibilities are what? There is a way of writing it. Only the persons who have studied logical design or Boolean algebra in their engineering or in +1, +2, they will know how to write these things. HH, HT, TH and TH. So how to start? You have two coins, no? Write 2H first, then 2 T's. Then 1H, 1T, 1H, 1T. Yes? Okay. Fine. So totally 4 events are there. First half, you write 2 H's. Second half, you write 2 T's. Here, alternatively, HT, HT. Yeah. Now tell me, what is the probability of getting both heads? So total number of events are 4. In that, getting both heads is one event, no? This is one event. This is another. This is another. This is another. So possible events are 4. Getting both the heads is 1. So what is the probability of getting both the heads? 1/4. Yes. Then probability of getting both tails? 1/4. Yes. Probability of getting one head and one tail. You can consider both of them. 2/4. So half is the probability for getting what? One head and one tails. Now I will change my question. Probability of getting at least one head. At least one head. This is one chance. This is another chance. This is. Here we have to discard. 3/4. What is the probability of getting at least one tail? 3/4 only? Yes. What is the probability of getting either 2 heads or 2 tails? 2/4. Yes. Probability of getting maximum 2 heads. Probability of getting maximum at the most 2 heads. At the most 2 heads. When we say at the most 2 heads, it is 2 or less. You have to consider 1 0. So when I say the probability of getting at the most 2 heads, it is a sure event. It is a sure, certain event. Yes, similarly, probability of getting at the most 2 tails. Sure thing, no? Sure thing? Yes. Okay, probability of getting at the most 1 head. At the most 1 head means you should not consider 2. 1 or less you can consider. At the most, 1 head, 1 or 0. So 3 events, 1 head, no head. Understood? So when 2 coins are tossed, this is easy. Now I'll go for 3 coins, and the number of sample space is 2 to the power of 3, not 3 to the power of 2. It is always 2 to the power of n, 2 to the power of 3. So 8 events will come. For the first coin, you can divide into 2 halves. You can write 4 H's here and write 4 T's. For the second coin, write 2 2. Double H, double T, double H, double T. For the last coin, 1 H, 1 T, 1 H, 1 T, 1 H, 1 T, 1 H, and 1 T. We got all the possibilities. How many possibilities are there? 8 possibilities. Now answer my question. What is the probability of getting 3 heads? 3 heads. Only one chance, no? 1 by 8. What is the probability of getting 3 tails? 1 by 8. Correct? Probability of getting exactly 2 heads. Exactly 2 heads. This is 1, second, third. That's it. 3 by 8. Getting exactly 2 heads. So, sorry, getting exactly 2 tails. 1, 2, 3. 3 by 8. What is the probability of getting at least 2 heads? At least 2 means 2 or more. 2 and 3. 1, 2, 3, 4. That's it. 4 by 8. Nothing but 1 by 2. What is the probability of getting at least 2 tails? Same thing. Now, probability of getting at least 1 head. At least 1 means you have to leave out 0. At least 1 means 1 or more. In all the cases, at least 1 head is there, no, except the last one. So 7 by 8. What is the probability of getting at least 1 tail? Same thing. 7 by 8. Got the thing? Got the thing? Only this thing is like, how to write. This thing is an art that you have to learn. Okay? Fine? Yeah. Done? Can we answer a few questions based upon this? Based upon this fact? In a throw of coin, what is the probability of getting head? 1 by 2. 2 unbiased coins are tossed. What is the probability of getting at least 1 tail? At least 1, except 2 tails, you have to consider all. So 3 by 4. Three unbiased coins are tossed. What is the probability of getting at least 2 tails? 4 by 8. 2 tails, at least. 1, 2, 3, and 4. At least 2 means 2 or more. Yes? So that is 4 by 8. Half, no? Yeah. Next. It is a what? Dice. So I'll show you dice. So on a dice, what all numbers will be there? 1 to 6. 1 to 6. Okay. So when one dice rolled, sample size is how much? Sample size, number of events that can happen. All possibilities are what? 6, no? Yes. Okay. When 2 dices are rolled, sample size 6 for first dice and 6 for other dice. Correct? Yes or no? So what all are those chances? What all are those chances? This first one is very basic. 1 and 1, no? Both the dices are reading 1. Second, first is reading 1, second is reading 2, or second is reading 1 and first is reading 2. Here, when you add the dices or the numbers on the dice, it is 2. When you add here, it is 3. Now, I'll go with 1, 3, 3, 1. Now I am getting the sum of 4. I am getting the sum of 4. Other chances? Now I am going for the sum of what? What? 5. 4 is done. Again start with 1. Interchange. 4 and 1. Now start with 2. Interchange. Yes. Next. Now I am going for 6. Correct? For 7. Yes or no? Now coming to 8, I can't start with 1 because 1 plus 7, I can't get 7. So now I'll have to start with 2. For 9, for 10, for 11, for 12, see it looks like Rangoli. Yeah? 1, 2, 3, 4, 5. 15 here. 1, 2, 3, 4, 5. 15 here. 6. 36 possibilities. So here, this will give me the sum of 2. This will give me the sum of 3. This will give me the sum of 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, align them properly. Align them properly. These are the possible events. Yes or no? 36 events. For 7, for the sum of 7, we get the maximum number of possibilities, 6. For 12, only 1. For 2, only 1. Got it? No issues. Okay. Can we Answer based upon these things. Don't go for three dices, okay? It will make your life complicated. 3, yeah, you can calculate anyways. Not a problem at all. But not required for our levels. In a throw of dice, what is the probability of getting number greater than 5? Number greater than 5 is only 6, no? 1 out of 6. What if they had asked the probability of getting number more than or equal to 5? More than or equal to 5. What if they had asked the number lesser than 5? 4 by 6, that is 2 by 3. What if they had asked less than or equal to 5? 5 by 6, done. Single dice, nobody will ask. We'll go to 2. What is the probability of getting some 9 from 2 throws of dice? Either 2 dices can be rolled simultaneously, or one dice is rolled one after another. Both are same things only. Either 2 together or 1 after another. Both are same only. Okay. So tell me, what is the probability of getting 9? The sum has to be 9. I have already solved. 3, 6, 6, 3, 4, 5, 5, 4. 4 out of 36. 36 is all possibilities, right? The number of all possibilities is 36. Out of them, we can choose 4. Yes, 4 by 36, that is 1 by 9. Is it tough? Is it tough? No, na? You can visualize, right? Have you played dice or not in your life? Yes? Before we introduced to dice, there were other instruments. Chaukawara, what you call. So there the possibility is from 1 to 4, then 8. Yes or no? 1 to 4 and 8. Then when this Ludo or snake and ladder, all these came, then we started playing what? Dice. Okay, then 6 possibilities. In this one Chaukawara, 5 possibilities. 1 to 4 plus 8. Yeah. 2 dice are thrown simultaneously. What is the probability of getting 2 numbers whose product is even? Whose product is even. See, how do you visualize the dice 1? Dice 1. What all are the possibilities? 1, 2, 3, 4, 5 and 6. Dice 2. Possibilities. 1, 2, 3, 4, 5 and 6. How do you get all these 36 combinations? How do you get all these 36 combinations? 1, 2, 3, 4, 5, 6. Like that for every number you will do 1, 2, 3, 4, 5, 6. So 6 into 6, 36 will get. So that is how we had written that one. Now they are asking the product should be even. So when you see a number on dice 1 and dice 2, and when you multiply, that has to be even. So what is the condition that we get a product as even? First of all, even into even, we get even, no? Even into odd, then also we get. If you falter in this, I'm sorry. Odd into even, this is not 0. This is odd. Okay. Odd into even. Only in the case of odd into odd, we get the product as odd. So here, try to discard this one, where you are getting the product as odd, and consider all other events. Out of 36 events, try to discard wherever you are getting the odd product. So when you are getting the odd product, because the probability of getting even product is more compared to getting the odd product. That is why we are calculating odd and subtracting. Yes. Now, odd products, how many? 1 into 1 is an odd? Yes or no? Then 1 into 3 is an odd. Then 3 into 1 is an odd. Correct? Yes or no? Then 1 into 5 is an odd. And 5 into 1 is an odd. Then what? 3 into 3 is an odd. Then 3 into 5 and 5 into 3 is an odd. Correct? 5 into 5 is also an. That's it. Or simple. Here see. This product is odd, this product is odd, and this product is odd. This product is odd, this product is odd, and this product is odd. Now, this product, and this product is odd. So totally 9 products are odd, right? So apart from those, all others will be even. So from 36, subtract 9. What you will get? 27. So the probability is 27 by 36, or that is 3 by 4. Okay. Done. So it is not just about sum. It can be of product also. Yes, it can be of difference also. Getting my point? It can be of difference also. Can you imagine? Difference. Yeah. If they tell the difference should be 4. Between 2 dices, the difference should be 4. So what all you will consider? 2, 6 and 6, 2. Then 1, 5 and 5, 1. Any other possibility? Any other possibility? No, right? Okay. If they ask, the difference should be 2. 1, 3, 3, 1. 2, 4, 4, 2. 3, 5, 5, 3. Then 4, 6, 6, 4. 8 out of 36. Yes? So like that they can ask anything. Or they might ask that the number that we are reading on the dice, one is the multiple of other. One is the multiple of other. What do you take? With respect to 1, you will take everything. Every number is multiple of 1. Yes or no? 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Similarly, 6, 1, 5, 1. Yeah. Then, when you take 2, you have to take either 4 or 6. 2, 4, 4, 2. 2, 6, 6, 2. Then, 3, take 3. 3, 6, 6, 3. That's it. Or no? For 1, when you have 1, it is 12. When you have 2, it is what? 4. And when you have 3, it is 2. Don't go to all those things. I am telling you, these all are the possibilities. This can come. Next question. In a box, there are 8 red. See, yesterday we had got similar problem, right? 8 red, 7 blue, and 6 green. So totally how many are there? 21. One ball is picked up randomly. One ball is picked up randomly. What is the probability that it is neither blue nor green? Simple, no? 8 divided by 21. Don't confuse yourself, okay? That is the answer, 8 by 21. You might think, overthink, that why will UPSC give this simple question? Yeah? So basically what? When you put your hand in the bag, when you get, it should not be blue or green means it should be red. So red possibility is 8 by 21. Now, card. Do you remember the basics? It starts from A, then 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, then Queen, then coming to this one. You must be feeling, sir is more interested in like drawing all this thing. He doesn't mind how many times he draws all these things. Huh? Shankar Pade. So how many? 52, right? Done? Now, how many spades will be there totally? Don't count, okay? Remember this, 13. How many clubs will be there? Similarly, how many hearts? 13. How many diamonds? Okay. How many aces? How many twos? 3, 4, 5, 6, 7, 8, 9, 10. All fours. Then Jack, 4. 4 jacks, 4 queens, and 4 kings. And these are black in color. And these are red in color. Okay, these are black in color. And these are red in color. Done? So how many black cards? 26. 13 plus 13. Spades and clubs will be in black color. 26 and 26. Right? Sure? How many face cards will be there? Face. Whose face is printed? Whose face is printed? 12. Jack, Queen, and King. For all of them, these 4 suits. Yes, 4 into 3. Ace is not a face. It doesn't have face. It will be printed with A. But it can be considered as a number also. It can be considered as high card also. High card. J, Q, K, A are considered as high cards. Getting my point? High cards. Because some like priority is given to them while we are playing the cards. So when you have those cards, that means those are high cards. The value will be more. Value will be more. Okay. So face cards you understood. These 3 into 4, 12. High cards. These 4 into 4, 16. And normally spades are 13, clubs are 13, hearts are 13, and diamonds are 13. Red cards are 26 and black cards are 26. Then these are the basics. Now depending upon this, we have to find the probability. Now, a card is drawn from pack of cards. The probability of getting Queen of Club, or King of Heart. Either you have to get this or this. How many cards are there totally? Totally 52 cards are there. And when you draw, what all are the possibilities that you have? Either it has to be a what? Queen of Clubs and King of Hearts. Yeah, this is 2. Possibilities are 2. So 2 by 52 is that okay? Is that okay? Yeah. Next. From a pack of 52 cards, one card is drawn at random. Find the probability of king or a queen. So totally how many cards will be there? King or queen. So totally if you take the number of kings, how many? Number of queens? Totally how many? Kings or queens? 8 by 52. This is nothing but 2 by 13. Simple. In examination hall, you can't say, sir, I don't know card games. I'll dispute this question. Some things have become general knowledge. Even UPSC can't go to that, like level ki few people will not be knowing card games. No, it will not mind. Okay. For example, tennis is a popular, like game. Table tennis. At least you should know, like how many players will be there, how do they play. Okay. So if you know that much, you can solve the problem. But this card game is a bit complicated, yeah, compared to other games. And in other games, like again, like how many sets of match, how many players are playing, so against each other, how many matches will be played, all those things you should understand. So there should be a, what I can say, the awareness about these games. Okay. Now, 8 by 52, 2 by 13 is done. Next, from a pack of 52 cards, one card is drawn at random. Find the probability of king or a spade. King or a spade. How many kings will be there? How many spades will be there? 13. So totally 4 kings, 13 spades. How many? Kings. How many? 4. Spades? Why 16? Because this king of spade has to be counted once, either under spades or under kings. We should not count them double. Or you can take like this. These are kings and these are spades. So totally how many kings will be there? 4. How many spades will be there? 13. There will be one common card. That is a king of spade. So that person will come here. Then 3 will come here. 12 will come here. 3 plus 1 plus 12? 16. So here 16 chances are there. So number of possibilities 52. Among them 16 are the possibilities. 4 4s are and 4 13s are. So answer is 4 by 13. Done. Cool. So far we are drawing one card. Let's see if we have 2 cards now. But it's not there. Okay, if you want extra this thing, extra question on that, cards, I'll tell you. Definitely, there are no 2 cards questions. Only 1 card is there. Okay. You can just take this question, like from a pack of 52 cards, 2 cards are drawn. Just, take the question. You can just say 2 cards are drawn. 2 cards are drawn. Full stop. The probability of getting two kings. Probability of getting 2 kings. So out of 52 cards, how many you are picking? 2. So out of 52, you are picking any 2, right? So what is the combination? Out of 52, you are picking up 2. So what is the combination? 52 C2. And you have to draw both of them as kings. These are all possible events. When you draw 2 cards out of 52 cards, these are the number of events possible. That is 52 C2. Yes or no? Yesterday when we were making, 2 teams play at a time out of few. Then also we had taken like this only, right? So when we are drawing 2 cards out of 52 cards, the possible events are what? 52 C2. Out of them, how many are kings? 4, no? In these 4 kings, we have to get 2 kings. So this is the expression for probability. Getting my point? In this question also, what we would have done, out of 52 cards, we are drawing 1. In that, out of 16 cards, we have to pick up 1 card. Same thing, no? 16, C1 is 16, 52 C1 is 52. Okay, so in this case, 4 C2 divided by 52 C2. So how do you write it? 4 C2. Start with 4. Stop after 2 entities, and in the denominator write 1 into 2. In the denominator, again 52 into 51 divide by 2 into 1. Actually, we can discard this 2 into 1 and 2 into 1 in the initial phase only. What you can do? 4 into 3 divided by 52 into 51. 4 ones are 4 13s are, 3 ones are 3 17s are. So this is 1 divided by 221. Or very simple method. You are drawing 2 cards, no? Think of only first card. What is the probability of drawing 1 king? What is the probability of drawing king from the pack of cards? 4 by 52. 4 kings and totally 52 cards. So out of 52 cards, you can have 4 kings. Now you have removed 1 card and kept it aside. How many cards are remaining now? 1 king you have removed and kept it aside. Now totally how many cards are remaining in the pack? So 51 cards are remaining. Out of them, how many kings are left? 3. So possibility of picking up this one is what? Our event will be over when we pick both the cards. Same thing, no? This expression and this expression. Think of first event, that is drawing a king, is 4 by 52. You will remove that card and keep it outside. Then what will happen? 51 cards are remaining. Out of those 51 cards, what you are trying to do? You are trying to pick up a king, but there are only 3 kings. So that is 3 by 51. 4 by 52 into 3 by 51. Done? Yes? Similarly, take same question. Instead of king, you put diamonds. Same question, what I have made you write, no? Same question, but make it 2 diamonds. 2 cards are drawn. What is the probability of getting 2 diamonds. How do you do that? Totally 52 cards. Out of that, again you are drawing 2. 52 C2. And how many diamonds are available? 13 diamonds? Yes or no? 13 diamonds, and out of them you are picking up 2. Correct? So how do you write it? 52 into 51. I am not writing 1 into 2 because in the numerator also I have to write 1 into 2. I'll discard that one. Can I take that much privilege? Instead of writing 1 into 2 here, like I'll not prefer writing that because I have to cancel with this. So in the numerator, I'll directly write 13 into 12. 13 ones are 13 fours are 4 ones are 4 threes are 3 ones are 17s are. So probability of getting 2 diamonds is 1 by 17. Okay, fine. So you have to see the condition. You have to see the condition and solve. In some questions, they'll give like after you remove the card and see it, you are placing it again. You are not removing it and keeping outside. For example, in this question only, out of 52 cards, I'll remove one. I'll pick one. Okay, that has to be what? Diamond. I'll replace the card back. So first probability is what? You have picked up one card out of 52. 13 are the possibilities. You have replaced that card. That means you have kept back that card. Again, what is the chance of seeing a diamond? Again, out of 52, you will see 13 diamonds. 13 ones are 13 fours are. Here 13 ones are 13 fours are. So this is totally 1 by. Depends whether you have been asked to replace the card back or not. That depends. Most of the cases, you will not be asked to replace the card. You will be asked to remove the card and keep it aside. Okay, fine. So getting the hang of cards, yes, just you have to think whether it is a numbered card or it is a suit. Spades, clubs, diamonds or hearts. You have to see that one. Depending upon that, you have to decide. Okay. Now last question. Last question. Don't write. Same question. 2 cards are drawn. The cards have to be either kings or diamonds. Cards have to be either kings or diamonds. In the denominator, same thing, 52C2. In the numerator, I have told either king or diamonds. So how many kings or diamonds will be there? 4 kings, 13 diamonds, but one will be common. That is king of diamonds. So 16. So 16C2. 52C2 in the denominator, 16C2 in the. Okay. Last question. Previous was last question. Now it is the last question. Okay. What is the probability of getting either a black card or a king? Black card or a king. Now tell me how many cards will be either black or king. Totally, how many black cards? 26. How many kings? 4. How many common cards? Because 2 kings will be black. Spade of king will be black. Club of king will be black. So 26 plus 4 minus 2. 28. So in the denominator we will write 52C2 and in the numerator we will write 28C2. So like this you have to decide. When you know the method of this C2 in cards, C2, it becomes very easy. Just you have to think of a number which you have to write in the numerator. That's it. Yes? Is that done? For only one card, it is not an issue at all. You take 52 in the bottom and those many numbers in the numerator. But when it comes to two cards, extra thing is C2. In numerator also you are writing C2. In the denominator also you are writing C2. They will not go to 3 cards for sure. If at all they go, then C3. Think of a condition. Anyways, in the denominator you are writing 52. Under that you will write C3. In the numerator you are deciding case by case and you are writing those many C3. That's it. Simple. No issue. Cool. I'm not saying that cool, you know. This is very good question actually. Very good question actually. A box contains 5 green, 4 yellow and 3 white balls. 5 green, 4 yellow and 3 white balls. 3 balls are drawn at random. 3 balls are drawn at random. What is the probability that all of them are of same color? Treat it like cards. What all we have seen different. What suits, you have seen different colors, you have seen different numbers. This is only simple, straight. This is one dimension, not 2 dimension, 1 dimension. It is only color. 5 green, 4 yellow and 3 white. So how many balls are there totally? Totally 12. Out of those 12 balls, how many you want to choose? How many you want to pick? So in the denominator, what should I write? 12 C. Now think of these different events. In the first event, you are drawing only what? You are drawing only all of them should be same color. Think of only green. You have to choose only green. So what is the probability of getting 3 green balls out of 5 green balls? 5C3, simple. Are you getting the idea? Yes, it is just like our king, spade, all that thing. So there are 12 balls. We are picking up 3. That is why 12C3 in the denominator. In the numerator, the possibilities for getting a green ball is 5. Out of them, we are choosing 3. So 5C3. This is for what? When I choose 3 green balls, my event is done. This question, this answer I want from you. When I pick up 3 balls, which are green in color, all of them are green in color, my one event is over. That will come. Okay, I'll write that too, then we'll ask this question. What about the yellow balls? 12C3 again. 4C. Then 12C3. This is for what? This is for done. Now tell me, what should I do here? Addition or multiplication? Addition. See, I had to choose 3 balls. I have chosen 3 balls, yes or no? My job is, but there are different cases. This is case 1. This is case 2. This is case 3. When we have different cases, correct? If here I had chosen only 1 ball, here if I had to choose the second ball, here if I had to choose the third ball, then this whole event is 1, yes or no? Then I would have multiplied. Getting my point? I'll give an example also in this question. So now let us calculate for this. Anyways, 12C3 is common. 12C3 is common. In 5C3, how do you write? 5, 3 divided by 3 into 2 into 1. Here also 4 into 3 into 2 divided by 3 into 2 into 1. 3 into 2 into 1 divided by 3 into 2 into 1. In all the cases, you are getting 3 into 2 into 1. In the numerator, you are getting 3 into 2 into 1 in all the cases. Yes or no? So that is why I will not write that one. Here also in 12C3, you will get what? 12 into 11 into 10 divided by 3 into 2 into 1. I will not use that 3 into 2 into 1 at all. So what I will do in this, I will write 12 into 10 into 12 into 11 into 10, and for the first expression, I will write 5 into 4 into 3 plus 4 into 3 into 2 plus 3 into 2 into 1, because the common 3 into 2 into 1 I have discarded from all the things, all the expressions. Not needed, no? Yes or no? So now see, you keep this 12 into 11 into 10 like that only. Anyways, we are going to simplify that one. 5 into 4 into 3, 60. 4 into 3 into 2, 24. Plus 3 into 2 into 1, 6. So totally this is 60 plus 24 plus 6, this is 90. Divide by 12 into 11 into 10. 0, 0 get cancelled. 3 3s are and 3 4s are. So this is 3 by 44. I'll just tweak the question. You can take, in the last, in the second page, just write the question number. What is the question number of this? 11, no? Make the question number as 11A. Question number as 11A. 11A. What I have done here, all of them are of same color. Now I'll do all of them are of different color. Okay. Fine. Cool. Not cool. Now, I'll write the expression. Anyways, I am picking how many balls out of 12? 12 C3. Correct? Now, all should be of different colors. Let's say I'll start with green. What is the chances of picking one green out of it? 5C, 1. What is the chance of picking one yellow? What is the chance of picking one red? Now what should I do? 5C1, 4C1, 3C1. What should I do? Multiply. Because my event will be over when I pick all of them. Yes or no? Just by picking the green, my event will be over. Just by picking this yellow, my event will be over. Just by picking red, just by picking white, my event will be over. By picking all of them, my event will be over. Yes or no? So I have to. So what is this? 5 into 4 into 3 divided by 12C3, that is 12 into 11 into 10 divided by 3 into 2 into 1. 3 ones are 3 fours are 2 ones are 2 twos are. Then 5 ones are 5 twos are 2 ones are 2 twos are 2 2 get cancelled. It is 3 by 11. 3 by 11. So choosing balls of different colors is easy compared to choosing all 3 balls of same color. Yes or no? Yeah. Okay. Fine. Yeah. So are you getting the gist? What is the difference between this expression and this expression? What is the difference between this expression and this expression? Yeah, this is same color, all 3 same color. So this is one independent event, this is one independent event, and this is one independent event. That is why we added. Here, all of them are dependent events on each other. First event will not be over until the next 2 events are over. Getting my point? Yes? So, there, multiply. And one more clue. Look at this, C3, C3. You don't have to multiply anything after that. When these are same, C3 and C3, you don't have to multiply anything. If it was C2 and C2, you don't have to multiply anything. Yes? C3, C3, you don't have to multiply. C3, C3, you don't have to multiply. But there, C3, but C1 there. Even if it was C2, then we had to multiply with something. Getting my point? So that is the clue. When you have C3 and C3, you are left with only addition. When you have the different things, here C3, there C2 or C1, then you have to multiply. Getting my point? Because there we have chosen only one ball. Our event is not over it. Here we have chosen all 3. Our event is over. But different cases are there. That's it. Got it? Can you remember these things? It will come only by practice. While you are... See, if you practice 5 to 10 questions today itself, you will never forget this concept. In the examination hall also, it will just click. Okay? Fine? But these questions are common questions. We are getting them into the examinations. But They are moderately tough. If your imagination goes wrong, then the whole problem will go wrong. Done? So I would request you to practice a few problems of same kind. Okay. Are you all with me for another 15 minutes? Yeah. A bag contains 6 red balls and 9 blue balls. 6 red and 9 blue. 2 successive drawing of 4 balls are made. See, they are not picking 1, 1, 1. They are picking 4 together. And they want what? Balls are made such that the balls are not repeated before the second draw. That means if you draw 4 balls, you have to keep it aside. If you draw 4, you have to keep it aside. Find the probability that the first draw gives 4 red balls and second draw gives 4 blue balls. First of all, how many balls are there? How many balls? Out of those 15 balls, how many you are drawing at a time? 15. In the first draw of 4 balls, how many balls? I mean, which balls you have to draw? Red balls, no? How many red balls are there? Correct? In the next draw, how many balls you are drawing? How many? 4 balls, sure? Yes or no? But how many balls are remaining now? 11 balls are remaining, right? Out of those you are drawing? Yes? Pakka? In that event, what you have to draw? Blue. How many blue balls are there? Out of that? Now, this is a special problem, like so far we used to draw 1, 1, 1, or you can just see the basis used to be the same earlier. Yes or no? Look at this question. Bases are same? Yes or no? There also base is same? So here this is a different thing. So usually bases used to be same. But in this case, what is happening? After the 4 balls are drawn, we are keeping it aside. And what is the event here? Find the probability that the first draw gives 4 red balls and second draw gives 4 blue. So my event will be over when? When both the things are done. So what should I do? Good. Fine. This is a special case. In the previous case, I had told, when you have same things here, you don't have to multiply. Yeah, that is what I had told. But here, this is different from this. Okay, so let us calculate. Again, when you write C4, in both the numerators and denominators, unnecessarily you will be writing 1 into 2 into 3 into 4, 1 into 2 into 3 into 4, 1 into... So I'll forget those things. So here I'll write 15 into 14 into 13 into 12. Fine? Yes or no? Yeah. In the numerator, 6 into 5 into 4 into 3. Here in the denominator, 11 into 10 into 9 into 8. Here, 9 into 8 into 7 into 6. Correct? 9 into 8, 9 into 8 get cancelled. Yes? Yes or no? Here 5 ones are, 5 threes are, 3 get cancelled. 6 ones are, 6 twos are. Then 2 ones are, 2 twos are. 2 ones are, 2 sevens are. 7 get cancelled. So what all are remaining now? 2 threes are, 2 fives are. So only 3 is remaining in the numerator and in the denominator. 13 into 55. 750. 750. Very special question. If you are not comfortable, that's okay. But when we know the method, why to leave such problems? Yeah? Always think, in the first draw what we are doing. In the second draw what we are doing. And is our work done after the first draw? Okay, if it is not, then you have to multiply. If the work is over in the first draw itself, and the second draw is another case, then you have to add. If your work is not over, even after the second event, then like you have to seek the third event or totally see how many dependent events are there and multiply. So here the very crucial thing is multiply and addition. When you understand the value of these multiplications and additions, it is done. For dependent events, when only small part of the task is done, then you have to multiply. When the entire event is done and another entire event is going to be done, those are different cases. Case 1 and case 2 or sometimes case 3. Then you have to add all of them. Okay, done? Yeah. And while skipping these steps of writing C4, that is dividing by 4, 3, 2, 1. If you are not comfortable of skipping, better do one more step and get the correct answer. In hurry, there are chances that you will underdo something or overdo something. Okay? Even if you are consuming 10 seconds extra, that is okay. You write in the normal method only. Okay? Until you get a proper expertise in solving. Okay? This is also a fantastic problem. A bag contains 15 red balls. A bag contains 15 red balls and 20 black balls. Okay? Red balls and black balls. How many red? 15 red. And how many black? 20. Each ball is numbered either 1, 2 or 3. 1, 2 or 3. 20% of the red balls are numbered 1. 20% of the red balls numbered 1. So 20% of 15 is how much? Sure. 20% of 15. And 40% of them are numbered 3. 40% of this 15. Now how many are remaining? 3 plus 6, 9. So 6 are remaining. They are numbered 2. Then similarly, among black balls, 45% are numbered 2. 45% of 20 is 9. Yes or no? Then 30% are numbered 3. 30% of 20. How many are remaining? Correct? So red ball numbered 1, 3. Red ball numbered 2, 6. Red ball number 3 is similarly 5, 9, 6 here. A boy picks up a ball at random. How many balls are there totally? Total balls. So out of these 35 balls, he is picking up one ball. 35C1, nothing but 35 only. Yes? 35C1 or 35. He wins if the ball is red and numbered 3. If he picks up one of these 6 balls, or if it is black and numbered 1 or 2. If he picks up either this ball or these balls, he wins. So what is the probability of getting this out of 35? 6 plus these 14. How much? Simple, no? Yes or no? This is just to, make you more confused. So basically what? Totally 35 balls are there. Out of them, if he picks up 20, one kind of balls 20, then he wins, that's it. All these are to make you more confused. Getting my point? Yes or no? Or you become the master here. Master, you are conducting a game. You prepared all these things. You have these many props with you. And you put them in a box. You call a player. You will give this condition to him. If you pick any of these balls, then you win. Simple, no? 35 balls are there. 20 such balls are there. By picking up which, he will win. So 20 out of 35. 4 by 7. Fine? Yeah. Last type of question. A speaks truth in 75% of cases. B speaks truth in 80% of cases. In what percentage of cases are they likely to contradict each other? A and B, A, B. A speaks truth and he lies. So A speaks truth in how many cases? So what are the chances of him lying? 25%. B, how many cases he tells truth? And what are the chances of him lying? Contradicting means what? Contradicting. One is doing something, other is doing something else. Yes or no? Yes or no? So when A is telling truth, what should B do? He should lie. When B is telling truth, he should so now do 75% into 20%. First case 1. A speaks truth and B lies. That is 75% into 20%. 75% into 20%. That is nothing but 15%. What about case 2? B speaks truth 80% and A lies. That is 25%. So total is 80% of 25%. I don't know how do you do it. I'm not going to teach you now. I have already taught you. Okay. So total contradicting probability is 35%. Contradicting probability is 35%. Yes. So it is as good as what? One is head, another is tail. One is tail, another is head. What cases they speak truth, both of them? 75% to 80%, that is 60%. In what cases both of them will lie? 25% of 20%, that is nothing but 5%. 60%, both of them telling truth. 5%, both of them telling lie. And 35%, they are contradicting each other. Similar. A problem is given to 3 students whose chances of solving it are half, 1/3, 1/4 respectively. What is the probability that the problem will be solved? Let's say A, B, C are there. A, B, C are there. Chances of A solving is how much? Chances of B solving? Chances of C solving? Now tell me, when will be the problem solved? You have given one problem to 3 people. When will the problem get solved? Should all of them solve? Then what is the use of giving it to 3 persons? When we are getting the result of that problem, that means all of them are solving. Any one of them is enough, no? Should we get all heads to win? If anyone gets head, one, no? When we will lose? When the problem cannot be solved. When all of them fail? Why you are staring at me? Tell yes or no. When the problem will not be solved. When all of them fail. What is the chances of A failing? Chances of winning is this. Losing. Chances of B failing. Chances of C failing. So chances of all of them are losing. In all other cases they will solve, no? At least one will solve. At least one head will get. In this case we are getting all tails. All are losing. Yes or no? So here chances of losing or chances of not solving the problem is 1/2 into 2/3 into 3/4. 3 get cancelled, 2 get cancelled. This is 1/. So only in 25% of the cases the problem will remain unsolved. Problem will remain unsolved. Otherwise, problem will be solved. In 75% of the cases, problem will be solved. Yes? Yes or no? Our mind will work like this. When all of them solve, then only we'll get the result. No. Even one of them, even 2 of them solve. Only when will we fail? When all of them will fail. So what are the chances of their individual failure? Half, 2/3 and 3/4. Multiply that. Yes. This is as good as all of them are lying. Then only we'll not get to know the truth. Yes. If one speaks truth, that is enough for us. Yes or no? Yeah. Similar problem, ABC solving the problem are 1/3, 2/7, 3/8. If all 3 try to solve the problem simultaneously, find the probability that exactly one of them will solve. Exactly one of them will solve. So here A, here B, here C. When A solves, what is the chances of getting the result? 1/3. That time B should not solve. That is what they have meant, no? B should not solve. Any one of them should solve. So here, this is 1/3. B not solving, chances of not solving. C, chances of not solving. Similarly, next attempt, B has to win. A and C has to lose. Last, C has to win. And B and A have to lose. See, this is one event. Only A solving. So this is the probability. Second case, only B solving. This is the probability. Last case, only C solving. Case 1, case 2, case 3. Add all of them. So what will get here? 25 by what? Same thing, 3 into 7 into 8, 126. Here, 2 into 2 into 5, 20 by 126. Then 2 into 5 into 3. That is 30 by 126. Add all of them. That is 75 out of 126. 3 25s are and 3 42s are. So 25 by 42. Here I have gone wrong. $168, okay. So here also 168. We'll get here 56. So last problem is also of similar kind. Solve it. Okay, fine. Solve it. Otherwise, I'll solve it in tomorrow's class. Okay.